Okay, well, welcome back. So we got two videos here, of course, as we make it maths, and we got two on tangents to a circle. So let's crack it. We've got quite a few examples to get through. So one thing just to remind yourself that, remember tan rad. So the tangent is perpendicular to the radius. So we're going to need that going for this. Okay, so let's jump in. We got this circle, x squared plus y squared equals 20. Now, what's the center of that circle? Okay, so it centers at the origin, 0, 0. And what's its radius? Now, the radius is square root 20. So it's just always that reminder that this is r squared. So go for it, pop a pause, and just do a very quick sketch of what that graph looks like, that circle looks like. Okay, so if we do that, we go, cool, there's our great Cartesian plane. The center is at the origin, and there's our circle, right? Where if we looked at some sort of distance, that would be square root 20. So a very rough sketch. Now, in which quadrant is the point 2, negative 4? Well, we're at 2 and we're at negative 4, so we must be, I'm not going to do this too much to scale. Let's say that it's approximately down there, right? So we're in quadrant 4. Now, let's draw a tangent over here. Now, if I'd done this a bit more accurately, it would have been better, but there's our tangent. It's just touching the circle once over there at that ever expanding blob, right, of 2, negative 4. Now, we've got our center here, and our center's at 0, 0. Now, just think through this. We want to find, first of all, what the gradient of this is. Now, how are we going to use this thing here, this idea that tan is perpendicular to radius? How do you think we're going to use that to work out the gradient of this tangent? Do you have maybe an idea that we could try? Okay, well, perhaps not, but I'm going to give you, so I'm interested to see. Maybe you're like, oh, well, I'm going to do what you're about to do or something else more interesting. So I'm going to draw a radius here, seeing as tan rad, and I know that's at 90 degrees. So if I can work out this gradient of this radius, then I can work out the other gradient, right? Because it will, multiply, minus 1, all of that stuff. So let's work out this gradient, the gradient, I'm going to just call it MR, the gradient of that radius. Well, we'll always just go rise over run, and we're running along 2, we're rising by negative 4, so that gradient's negative 2. So therefore, and I'm just going to squeeze it in here so everything's all on one page. Therefore, what is the gradient of our tangent? Well, our gradient's just the negative reciprocal. So it's going to be a half, right? Minus 2, and you switch it around. So far we've got y equals mx plus c, and it goes through this point 2, negative 4. So how are we going to find out what c is? Well, I've done quite a few of these. In fact, earlier in the last few videos, we're doing some of these. So you sub in this point. So let's sub in this point here. Negative 4 equals a half 2 plus c. Okay, a half times 2 is 1. Subtract 1 from each side. Negative 5 equals c. So therefore, y equals a half x minus 5. So there it is. The main gist was draw in this radius, find the gradient of the radius, and then the other gradients, the negative reciprocal, because of this whole tan rad thing here. Okay, cool. So that's one example. Let's fly into another one. Okay, we're given this equation of our circle. Of course, let's switch it around. What's the radius of the circle? You did. I wonder if you wrote 1 because you're like, oh, well, that's 1, so that's 1 squared. But wait a second. We're going to need to do a little bit more work here, because this isn't in that center radius squared form. It isn't in the form x something squared plus y something squared equals the radius squared. We've got to do a little bit of work here first. So this part here, remember that to find out what the second value here, in other words, what the x value of the center is, well, we took that and we divided it by 2, right? Remember that idea. So that was minus 5 over 2. So if we squared that, cool, we'd get x squared minus 5x. That should work, that. But we'd end up with plus 25 over 4 But wait a second, we didn't have that, so we had that idea of compensating for that minus 25 over 4. So therefore we need to add it to both sides. So on the right hand side, we had our 1, but we're going to need to add in both sides of our equation. I think we did like this, 25 over 4. So we're going to have to add it in on that side as well. So a little bit of work just before you thought, oh, the radius was 1. Oh, yeah. So this other part, let's just have it here. Running out of what colors do we have last time? Plus y plus 3 squared. So therefore, that 1 plus 25 over 4. Well, beloved calculator tells us, what does it tell us? What is the radius really? Okay, well, we've got 1 plus 25 over 4 gives us 29 over 4, which means that our radius here is actually the square root of 29 over the square root of 4, so 2. So, or the square root of 29 over 4. Okay, so either way. So let's do that, and goodbye. Goodbye, calculator. Okay, so there we go. So we need to work out that what's the tangent here at the y-intercepts. So draw a quick sketch of this graph. So there it is. Draw a quick sketch of this circle. Hit OK when you're done. Okay, so we might draw here and we go, well, here's our Cartesian plane. We know that our center is at positive 5 over 2, negative 3, so somewhere over there. Our radius is square root 29 over 2. Let's just see what kind of a number is that. Square root ons, and that's about 2 comma something or other. So definitely going to intersect there, and that was minus 3. So I think that our sketch looked like, well, I think something like that. So we got our 2 y-intercepts over there. Now, what I just wanted to check was this radius here, this point, the center, is at 5 over 2 minus 3. But our radius, as we can see from the calculator up here, is less than 3. So therefore our circle doesn't cross the x-axis. Okay, so we want to find out what these y-intercepts are. So for this one, we've got a little bit more work to do. What do we definitely know about those y-intercepts? What value do we know? Well, the value that we know is the x value must be 0. So therefore, how are we going to find the y-intercepts? How do we find the y-intercepts of any graph? Well, we let x equal 0 because that's the bit we know. So from our equation here, we've got 0 minus 5 over 2 squared plus y plus 3 squared equals 29 over 4. Right? We don't know what y is, but we know x is that. Okay, so y plus 3 squared equals, well, 5 over 2 squared is 25 over 4. So if we subtract 25 over 4 from each side, then we've got, well, what do we get? What's on the right-hand side? Well, let's just check out your thinking. 29 over 4, and we're subtracting 25 over 4. Well, 29 minus 25, 4 over 4. Perhaps you just punched it into your calculator, and you got, well, that must be 1, right? Okay, so what are our 2 values of y? What are our y-intercepts? Well, either y plus 3 equals negative 1, because negative 1 squared gives you 1, or y plus 3 equals 1, so therefore y equals negative 1, negative 3, that's negative 4, or y equals 1 minus 3 is minus 2. Okay, so we can get those 2 values there. Okay. That was a little bit of work to get there, right? But now that we've got it, and of course I was in the way, but I'm sure you saw all of that. So now that we got those, let's work from our diagram. So I can leave that there and say, well, let's just go tangent by tangent. Let's start with this tangent over here. what are our steps going to be so we can find the equation of that tangent just very briefly. Well, what we can do here is, of course, do what we just did above. You got the radius, you know that's 90 degrees, so if you can work out this gradient, then you can work out the gradient of this tangent here. I'm going to call it M2. And then you're going to do the same thing for the other one. So let's go through it. It's going to be not too bad, right? Because we're going M1 equals rise over run. Well, let's go from left to right, I always like to do. So we're running by 5 over 2. And we're going from -2 down to -3. So we're rising by -1. So -1 divided by 5 over 2. You know what? Trusty calculator, right? -1 divided by 5 over 2 minus 2 over 5. Maybe you saw that it was going to be that reciprocal already. Okay, so therefore our gradient of that tangent is 5 over 2. And we know that y equals mx plus c. Right, pause, breather, all good? Okay, so we've got y equals 5 over 2x, and we just sub in that point there. So -2 equals, wait a second. Why am I being silly to sub in that point to find out what c is? Well, I'm being silly because isn't c just the y-intercept of the straight line? And aren't we given the y-intercept? So that's a little bit silly, isn't it? I feel like over here I could just go, well, we know that c is -2. Maybe you spot you, like, why is he going through that? Okay, so there we go. That's the first tangent. And for the second tangent, of course, we need to do it all again. Find out what this is. And then we're going to find out our second one here, which is going to go there. It's going to intersect the other one there somewhere. That's 90 degrees. So let's go through it. M3 equals rise over run. Well, we're running by -4, no, 0 to 5 over 2. Feels like we've done this bit before, 5 over 2. But this time we're rising by 1. Now what's 1 divided by 5 over 2? Well, 1 times 2 over 5, so 2 over 5. So therefore our gradient here of this line, M4 let's call it, M4 is, well, 5 over 2. Now wait a second, something doesn't seem right. That's a negative gradient, right? So what is the gradient of this tangent? Well, it's -5 over 2. Always just like doing those extra little checks. So that's that. So y equals -5 over 2 x. And we've got plus c, which is -4. Now, this just so happened that the gradients kind of were 5 over 2 and -5 over 2. You will have to work out each one. There's no like shortcut of going, oh, well, if the one's that, the other one's just the negative of it. Not always going to be the case. Just this one here. Okay, so I reckon we go for one last example. Let's do that one in the next video so that we still have our energy with us, right? So, of course, as we get ready to do that, make it maths, and I'll see you in the next one.